Have you ever wondered why trains carrying Bakken oil explode? You might have heard about the chilling incidents of train explosions that made headlines across the globe. These aren't just any trains, but those carrying a particular type of crude oil, Bakken oil. What makes Bakken oil different from other crude oils? Stay tuned as we delve into the science behind these fiery mysteries. First, let's understand what Bakken oil is. Bakken oil, named after Henry Bakken, the farmer who owned the land where the oil was first discovered in North Dakota back in the 50s, is a type of light, sweet, crude oil. This classification, light and sweet, refers to the oil's low density and low sulfur content, respectively. These properties make Bakken oil easier to refine into gasoline and diesel fuel, which is why it's been a significant player in the oil industry. The Bakken oil fields span across North Dakota, Montana, and into Canada, sit atop the Bakken Formation, a subterranean rock formation. This formation is rich in organic material that, over millions of years under intense heat and pressure, has transformed into oil and natural gas. But here's the thing. Bakken oil isn't just sitting in a big pool underground waiting to be pumped out. It's trapped within the pores of the rock formation, making traditional drilling methods ineffective. So, how do we get it out? Enter hydraulic fracturing, or, as you might have heard it called, fracking. Fracking involves drilling a well thousands of feet into the earth, then turning horizontally and continuing to drill into the oil-rich rock. A high-pressure fluid is then pumped into the well, creating cracks in the rock that allow the oil to be extracted. This method has allowed us to tap into vast reserves of oil that were previously out of reach, leading to a boom in Bakken oil production in the late 2000s. This boom has had significant economic benefits, creating jobs and contributing to domestic energy production. However, it's also led to some serious safety and environmental concerns due to the volatile nature of Bakken oil. Now that we know what Bakken oil is, let's explore why it's more volatile than other types of crude oil. Bakken oil is known for its volatility, but what does that mean? Well, volatility refers to how easily a substance will vaporize at a given temperature. It's a key factor in determining the explosiveness of a substance. The more volatile a substance is, the more readily it turns into vapor, and it's these vapors that are actually the source of the explosions, such as the vapors of gasoline. Now, the volatility of Bakken oil is rooted in its unique composition. Unlike other crude oils, Bakken oil has a high gas-to-oil ratio. This means it contains a higher proportion of natural gases, such as butane, propane, and ethane, compared to other crude oils. But that's not all. Bakken oil also has a low flash point. The flash point is the temperature at which a particular organic compound gives off sufficient vapor to ignite in air. A lower flash point means that the oil can ignite at lower temperatures. Thus, Bakken oil, with its low flash point, can ignite more readily, even under relatively mild conditions. Moreover, Bakken oil's high vapor pressure of 13.9 pounds per square inch contributes to its volatility, compared to other types of crude that have a vapor pressure of about 6 psi. This higher pressure can cause rail cars to fail and cause an explosion of the Bakken oil. The combination of these factors, a high gas-to-oil ratio, a low flash point, and high vapor pressure, make Bakken oil particularly volatile. But there's another element at play here as well, the extraction method. Bakken oil is typically extracted using hydraulic fracturing, or fracking, a process that can lead to more gaseous and volatile oil. And it's important to note that this isn't just a theoretical concern. This volatility has real-world consequences. We've seen a number of accidents involving Bakken oil, where the oil ignited and caused large, often catastrophic explosions. These explosions pose a serious threat not just to human life, but also to the environment, as they can result in significant oil spills and fires. So when we talk about the volatility of Bakken oil, we're talking about a complex interplay of factors, all of which contribute to making this particular type of oil more prone to igniting and exploding. It's a reminder that not all crude oils are created equal. So, how does this volatility translate to train explosions, you might be wondering? Well, let's delve into that. When we talk about oil train explosions, we're actually referring to a series of events that lead up to the catastrophic finale. The first of these is usually the sloshing of the oil that causes vapor psi to increase and rupture the rail car, and the explosion of the oil takes place. The second is a train derailment. Now, trains carrying Bakken oil traverse thousands of miles across the country, often through challenging terrain and weather conditions. Despite stringent safety measures, Derailments can and do occur due to a multitude of reasons, including track failures, equipment malfunctions, and human error. When a train derails, the oil cars often suffer damage, leading to the second event, punctures. These punctures allow the highly volatile Bakken oil to escape, creating an extremely dangerous scenario. The third event is the subsequent ignition of the volatile Bakken oil. This can happen in several ways. Sometimes the sparks generated during the derailment are enough to ignite the oil. Other times, an external heat source like a fire or another explosion can cause the oil to catch fire. Once ignited, the volatile Bakken oil burns fiercely, often resulting in massive explosions. These explosions are not just ordinary fires, they are intense, high-energy events that can level buildings, incinerate everything in their path, and send plumes of black smoke billowing into the sky. These chain of events, derailment, puncture, ignition, and explosion, are what make oil train explosions so devastating and so dangerous. And it's this destructive power that has led many to question the safety and environmental implications of transporting Bakken oil by rail. These explosions are not only devastating, but they also have a considerable impact on our environment. The environmental impact of these explosions is far-reaching. As we delve deeper into the repercussions of Bakken oil train explosions, it's vital to acknowledge the environmental consequences. These aren't just isolated incidents that end with the extinguishing of the fire. The aftermath lingers often for years in the form of oil spills, air pollution, and harm to wildlife. Let's start with the oil spills. When a train carrying Bakken oil derails and explodes, vast quantities of crude oil are discharged into the environment. This oil does not simply evaporate or disappear, it seeps into the soil, contaminating it and making it unfit for plant life. The oil can also find its way into water bodies, leading to extensive water pollution. Freshwater ecosystems are particularly vulnerable, with oil spills causing significant harm to aquatic life and disrupting the delicate balance of these ecosystems. The environmental damage doesn't stop at oil spills. Air pollution is another grim reality we have to face. When Bakken oil explodes, it releases a cloud of toxic gases into the atmosphere. These gases include sulfur dioxide and nitrogen oxides, both of which are harmful to the environment and human health. Sulfur dioxide can lead to acid rain, while nitrogen oxides contribute to the formation of ground-level ozone, a key component of smog. Both of these pollutants can have severe effects on human health, particularly on the respiratory system. Moving on to wildlife, the impact of these explosions can be devastating. Oil spills can coat the fur and feathers of animals, reducing their insulating abilities and making them susceptible to hypothermia. Ingesting the oil while trying to clean themselves can lead to poisoning, often resulting in death. Moreover, the disruption caused by the explosion and subsequent cleanup efforts can lead to habitat loss, forcing animals to migrate and potentially causing a ripple effect throughout the ecosystem. The urgency of addressing this issue cannot be overstated. Each explosion not only presents an immediate danger to human lives but also leaves a lasting scar on our environment. These environmental consequences are not just localized to the area of the explosion. Air pollution can spread far and wide, carried by the wind, while oil can travel vast distances in water, affecting ecosystems far removed from the original spill site. Furthermore, the cleanup efforts required after such an event are both time-consuming and costly. They also pose additional risks to the environment, as the methods used to clean up oil spills can sometimes cause further harm to the ecosystem. In conclusion, the environmental impact of Bakken oil train explosions is a significant concern. These incidents cause extensive damage to our ecosystems, threaten wildlife, and contribute to air pollution. It's clear that the volatility of Bakken oil poses a significant challenge to both safety and environmental conservation. The question now is, what can be done about it? With the alarming frequency of Bakken oil train explosions and their devastating impact on the environment, it's clear that solutions are urgently needed. Firstly, we need safer transport methods. Traditional rail tank cars, as we've seen, are not up to the task of safely transporting this highly volatile oil. Investment in advanced tank cars with thicker shells and better heat shields would significantly reduce the risk of explosions. Additionally, rerouting trains to avoid heavily populated areas could drastically decrease the potential human toll of these explosions. Regulations also play a crucial role. At present, the oversight of Bakken oil transportation is, to put it mildly, lax. Stricter regulations and robust enforcement would ensure that oil companies take the necessary precautions to prevent explosions. This could include mandating the use of advanced tank cars, enforcing speed limits for oil trains, and requiring comprehensive emergency response plans. However, the most sustainable solution would lie in reducing our reliance on Bakken oil altogether. The world is in the midst of an energy revolution, with renewable sources like solar and wind power becoming increasingly viable. By investing in these alternative energy sources, we could reduce the demand for Bakken oil, and consequently the number of trains carrying it. Innovation in energy storage and distribution could also lessen our reliance on dangerous oil transportation. Think about it. If we could efficiently store and distribute renewable energy, there would be less need for these oil trains. Lastly, public awareness and activism are crucial. The more people know about the risks associated with Bakken oil transportation, the more pressure can be put on governments and corporations to take action. While the issue is complex, it's evident that action must be taken to prevent these disastrous explosions and protect our environment. The solutions are within our grasp, and it's high time we reached out and seized them. Today we've explored the explosive nature of Bakken oil. In this journey we've peeled back the layers of a complex issue, one that intertwines the realms of energy, transportation, and environmental impact. We've come to understand that Bakken oil is not your run-of-the-mill crude. It's a unique beast, a volatile and unpredictable one that has put a spotlight on the risks associated with transporting it, particularly by train. We've discovered that Bakken oil's high volatility, largely due to its high levels of dissolved gases, is what sets it apart. This volatility is what makes it prone to ignite and cause catastrophic explosions when the trains carrying it derail. It's a chain reaction of sorts, the derailment leading to punctured tank cars, which then leads to the oil's exposure to heat or sparks, and ultimately, an explosion. This isn't just about the immediate aftermath of such explosions. We've delved into the environmental impact that these incidents have. Spilled oil doesn't just go away, it seeps into the soil, contaminates water sources, and releases harmful pollutants into the air. The environmental cost is steep and the recovery slow. It's a ripple effect that extends far beyond the site of the explosion. But it's not all doom and gloom. We've also discussed the measures that can be taken to mitigate these risks. Stricter safety regulations for tank cars, more rigorous testing of Bakken oil before transport, and alternative, safer methods of transportation can all play a part in reducing the likelihood and impact of such disasters. As we've seen, the issue of Bakken oil train explosions is a complex one. It raises questions about how we balance our energy needs with the need to protect our environment and ensure public safety. It's a conversation that needs to be had, one that needs to involve everyone from government regulators and oil industry leaders to environmentalists and everyday citizens. We hope this exploration has provided you with a deeper understanding of the issue. Knowledge, after all, is power. It's the fuel that drives change. And change is what we need to ensure a safer, cleaner, and more sustainable future.